Geometry, Unit 11, Section 2, Defining Regions. So Unit 11 is a coordinate chapter for geometry. Actually, 11 and 12 are coordinate chapters in geometry for us. And in 11, we really don't see the geometry connection yet. We're just kind of getting into some formulas and graphing lines and inequalities and things like that. But we're going to start to see, even in this lecture, that these things create shapes and we can do geometry properties with those shapes from coordinates and stuff like that. So the first thing we're asked to do here is graph the system of inequalities. Now, graphing inequalities is something that you learned in Algebra 1. So this should be review, but let me kind of touch on it anyways. We graph inequalities much like we graph lines. We have slope and y-intercept features. So I'm looking for a slope and a y-intercept. Now my equation does need to be standard form. What that means is we want y alone on the left and a slope y-intercept, mx plus b, alone on the right side. So if y wasn't alone here, like say this was y minus 1, I would add 1 to both sides before pulling out slope-intercept stuff. And then for inequalities, there's two things that are different than lines. First of all, we have to determine if it's a solid line or a dotted line. These are all solid lines because they have the equal to bar, right? This is less than or equal to, less than or equal to, greater than or equal to. And that equal to bar makes a solid line. If it doesn't have that, if it's just less than, it would be a dotted line. We're going to see mostly equal to bars here because we're trying to create regions, and we want those regions to have solid lines. But sometimes you'll see the dotted. And also, we shade a solution set. And so when it's less than, we shade below the graph relative to the y-axis, and if it's greater than, we shade above it. But let's hold off on the shading. In Algebra 1, I used to teach graph a line, then shade it, and graph a line, then shade it. But when geometry, when we're doing regions, because there's going to be 3 or more inequalities, the shading can get very, very messy if you do it one by one. So I'm actually going to wait to graph all of the lines and then only shade, the region that they're going to define. I'll show you that as we go, though. And there's actually an issue on this one over here. So while I have it in my mind, we're going to change this. Change this from y is less than or equal to 2. Let's change that to y is less than or equal to 4. I think that is going to give us a better example here. So just make that quick change for me. All right, so the first one, y is less than or equal to negative x plus 1. Here's our slope right here, that negative, and that negative really means negative 1, and that really means negative 1 over 1. And my y-intercept is the plus 1. That's a vertical shift of up 1 from the origin. That's why the y-intercept is 1. So that's where we start. We always start on the y-axis when we graph slope-intercept graphs. And negative 1 over 1 is down 1 over 1. And we always start by going to the right, and our negative slopes go down, our positive slopes go up. But then we do go up, but we go up left after we run out of space. Plot every point I can, and then I'm going to draw a solid line because it has the equal to bar. And this solid line, I'm going to use a tool to draw a straight line. You should too, whether it's a ruler, a straight edge, or the side of your compass, if your compass has one built in. And we put arrows on the ends. Now I could shade this. I would shade below it because it's less than. That would be this side. But again, it's helpful to use the y-axis as a reference there. This is the y-axis below the graph. That's why I would shade to that side. So all of this would be shaded. But I'm not going to do that yet because it'll make the graph a little messy if I do all of it. So we'll save that for now. Then the next one, it's in standard form. My slope is 2 over 1. My y-intercept is that plus 4, which is 4. So I start there. And up 2 over 1. Because it's a positive slope. Remember, your negative slope should look like decreasing lines, declines left to right, and your positive slope should look like increasing lines left to right. And so I am continuing that slope pattern of 2 over 1, changing 2 on the y-axis and changing 1 on the x-axis, and graphing a line. And putting arrows on the ends. And I could shade it now, but I'm not. I'm going to wait. But it is also less than, so it would be over here. If I were to shade as I go, it would be all of this. But I'm not going to shade that just yet. The last line here is y is greater than or equal to 4. Excuse me, yes, so we changed this 2 to a 4. And actually, I'm going to have to change something else too. I just realized that. Let's instead of 4, let's do -2. So I'm going to change this again. Let's do y is greater than or equal to -2. That's probably what it was supposed to be. I probably didn't have the negative sign there. That's going to work better. Sorry about that. Now, first of all, this equation does not have an x. What does that mean? Well, linear equations that don't have both variables, like this has x and y, those are slope-intercept ones. But if they only have one variable, if they only have an x or only have a y, that means horizontal and vertical lines. Now, which one is which? The way to remember that, the way that I like to remember that, is the variable it has is the axis it crosses. And it crosses at that number. So I will read this as crossing the y-axis at -2. And the way to cross the y-axis is with a horizontal line. So this is going to be a horizontal line. Equations that only have x, they are vertical lines because they cross x at that number. So y is greater than -2. It's going to greater than or equal to -2. It's going to cross -2 and it's going to be horizontal at that spot. So let me draw that line. And that would be that. Again, arrows on the end. So this has a slope of 0. It's a flat line. And what we see here is this is going to define a region. So for my green inequality, or let's do the blue one. We did the blue one first. If I were to shade less than, it would be all of this, and it would be kind of a mess. So instead, I see that these lines form a triangle. And I'm going to shade only in this triangle because what you're going to see is that this triangle is less than below the blue line. It's also less than below the green line. So if I shade for the green line, it'll be there too. And it's also greater than for the red. And so all of this whole region is formed by these three inequalities. If I shaded everywhere for all three of these, it'd be a mess and it'd be hard to even see the triangle. So I wait to see the region they define and see if the shading does match for all of those in that region, and it will. So here's creating a region, and from this triangle I made, I could do the area of this triangle, I could do the perimeter of the triangle, I could, do different things. All right, this time I'm giving you a region already drawn, and I want to write the inequality describing the x values, the y values in the system. So first, write the inequality describing the x values. That simply means the furthest this thing goes is -2, and the furthest right it goes is 2. So that'd be -2, 2. That's how we would say, all right, this graph is limited to -2 and 2 on the x-axis. There's no graph over here. There's no region over there. It's between -2 and 2 on the x, and it's between 5 and -5 on the y. So -5 less than or equal to y less than or equal to 5. This is kind of like domain and range. All right, but how about a system of inequalities for it? And basically, I want to create what is the line that would form this. And so you kind of have to think of these lines one at a time. This line right here, what do I know about it? It has a slope of up 1 over 2, right? This has a slope of 1/2, so 1/2 x, a y-intercept of 4, 1/2 x plus 4. And the region is below it, so that would be less than or equal to. For this one over here, very sloppy drawn line there, let me use these colors actually. So I'm going to do green for this one. I already have the blue, and then I'll do red for the last one, for the vertical one. So for the green one, oops, too thick. Sorry, that was the school bell just rang. Let me just finish this up real quick. So it has a slope, a negative slope of down 2 over 1. So that's a -2x and a y-intercept of -1. And the region is shaded above it, so that would be greater than or equal to. And lastly, I have a vertical line. And a vertical means it must be x because it's crossing the x-axis, and it's crossing the x-axis at 2. But is it greater than or less than? Well, for vertical lines, it's the one type of line I can't do above and below. I have to do, I have to use the x-axis, and I see it's to the left, so that is less than. So that is it, and I'm sorry if you're hearing bells and announcements behind me. Talk to you in class. See ya.